Hello everyone. Today we shall discuss about data handling. In the previous classes, we have dealt with various types of data. You have learned to collect data, tabulate and put it in the form of bar graphs. The collection, recording and presentation of data help us to organize our experiences and draw inferences from them. In this chapter, we will take one more step towards learning how to do this. We will come across some kinds of data and graphs. We have seen several kinds of data through newspapers, magazines, televisions, and other sources. We also know that all data give us some sort of information. Let us look some common forms of data that you come across. Suppose this is a table. Here it is given temperature of cities as on 26 2006. These are the various names of cities, that is Ahmedabad, Amritsar, Bangalore, Chennai, Delhi, Jaipur, Jammu and Mumbai. Here it is given maximum temperature and minimum temperature. This is a collection of data of temperature of cities. Here you see in table 3.2 Football World Cup 2006. Ukraine beat Saudi Arabia by 4-0. Spain beat Tunisia by 3-1. Switzerland beat Togo by 2-0. This is also a data, right? But you have to organize the data. Here, this is table 3.3, data showing weekly absentees in a class. Monday 3, Tuesday 1, Wednesday nil, Thursday 1, 2, 3, 4, 5, Friday 2, and Saturday 1, 2, 3, 4. One dot represent one child. These are various types of data represent. This is the form how you should represent the data in tabular form, or you can represent the data in graph also, right? These are various types of data and you have to collect, and from them we come across some inferences from them, right? Now the first way is to collection of data, right? Before, the data about the temperature of cities can tell us many things, but it cannot tell us the city which had the highest maximum temperature during the year. To find that, we need to collect data regarding the highest maximum temperature reached in each of these cities during the year. In that case, the temperature chart of one particular date of the year as given in table 3.1 will not be sufficient, right? That means before collecting data, we need to know what we would use it for. Given below are few situations. You want to study the performance of your class in mathematics, performance of India in football or in cricket, female literacy rate in a given area, or number of children below the age of 5 in the families around you. What kind of data would you need in the above situation? Unless and until you collect appropriate data. What is needed? You have to collect appropriate data. You cannot know the desired information. What is the appropriate data for each? The appropriate data means what you need, that is your appropriate data. Organization of data. First, after collecting, you have to organize the data to get particular information, right? For example, here it's a Neelam class teacher wanted to find how children had performed in English. She writes down the marks obtained by the student in the following way: 23, 35, 48, 30, 25, 46, 13, 17, 27, 32, 38. In this form, the table was not easy to understand. She also did not know whether her impression of the student matched their performance. Right? Neelam's colleague helped her organize the data in the following way. This is another form to represent the data. You can represent your data in the form of table or in the form of graphs. Right? Here, table 4 is here given. Roll number 1 is given 1, 2, 3, 4, 5. Names of the students: Ajay, Arman, Assis, Deepti, Faizan, and out of 50 marks he got 23, 35, 48, 30, 25. This is the table, right? In this form, Neelam was able to know which student has got how many marks, but she wanted more. Deepika suggested another way to organize the data. You have to first you have to collect the data. After that, you have to organize the data to get the desired result. This is table 4.5, 3.5. Here, in this way, you can also make the table, right? It is roll number 3, 6, 10, 2, 9 and name of a student. Out of 50 marks they got 48, 46. They are descending order. Then you can tell who got highest mark and who got lowest mark, right? It will be easier for you to interpret these tables. That means you have to collect the data, appropriate data, and then you have to organize the data to get the desired result, right? Now, the next one is representative value. You might be aware of the term average and would have come across statements involving the term average in your day-to-day life. ESA spends on an average of about 5 hours daily for her studies. The average temperature at this time of the year is about 40 degrees centigrade. The average age of pupils in my class is 12 years. The average attendance of students in a school during its final examination was 98%. Many more such statements could be there. Think about the statements given above. Do you think that the child in the first statement studies exactly for 5 hours daily? Or is the temperature of the given place during the particular time always 40 degrees centigrade? Or is the age of each pupil in the class 12 years? Yes, obviously not. Right? That means we have to find the mean for that, or you can say it as arithmetic mean. Right? Thus, we realize that average is a number that represents or shows the central tendency of a group of observations or data. That is a central tendency, right? Since average lies between the highest and the lowest value of the given data, so we say average is a measure of the central tendency of the group of data. What is that? Average is a measure of the central tendency of the group of data. Different forms of data need different forms of representative or central value to describe it. One of these representative values is the arithmetic mean. You will learn about other representative values in the latter part of the chapter. Now, what is that arithmetic mean? The most common representative value of a group of data is the arithmetic mean or the mean. To understand this in a better way, let us look at the following example. Two vessels contain 20 liters and 60 liters of milk respectively. What is the amount that each vessel would have if both share the milk equally? When we ask this question, we are seeking the arithmetic mean. In the above case, the average or the arithmetic mean would be total quantity of milk divided by number of vessels, that is 20 plus 60 by 2, that is 40 liters. Thus, each vessel would have 40 liters of milk. The average or arithmetic mean AM or simply mean is defined as mean is equal to sum of all observations divided by number of observations. Right? You can find the arithmetic mean in this formula, that is mean is equal to sum of all observations divided by number of observations. Here it is given some examples. Let us study these examples also. Example 1. Assis studies for 4 hours, 5 hours and 3 hours respectively on 3 consecutive days. How many hours does he study daily on an average? The average study of time of Assis would be total number of study hours divided by number of days for which he studied. Is 4 plus 5 plus 3 by 3 hours, that is 4 hours per day. Thus you can say that Assis studies for 4 hours daily on an average. A batsman scored the following number of runs in 6 innings: 36, 35, 50, 46, 60, 55. Calculate the mean runs scored by him in an innings. Thus, we can say the total runs is 36, 35, 50, 46, 60, 55, 282. To find the mean, we find the sum of all the observations and divide it by the number of observations. Thus, in this case, 22 by 6, that is 47. Thus, the mean runs scored in an innings are 47. Right? In this way, you can find the different arithmetic mean. Now, what is range? You have to know the range. What is range? The difference between the highest and lowest observation gives us an idea of the spread of the observations. This can be found by subtracting the lowest observation from the highest observation. We call the result the range of the observation. Look at the following example. The ages in years of 10 teachers in a school are 32, 41, 28, 54, 35, 26, 23, 33, 38 and 40. What is the age of the oldest teacher and that of the youngest teacher? First, arrange the ages in ascending order. We get 23, 26, 28, 32, 33, 35, 38, 40, 41, 54. We find that the age of the oldest teacher is 54 years and age of the youngest teacher is 23 years. Right? Range of the ages of the teachers. Range of the highest age is 54 and the lowest is 23. You have to subtract this one, that is 54 minus 23, that is 31 years is the range of the ages of the teachers. Mean age of the teacher, mean age, that is sum of the observation divided total number of observation. The sum of all these ages 23, 26, 28, 32, 33 plus 35 plus 38 plus 40 plus 41 plus 54 by number of observation, that is number of teachers, that is 10 teachers, it is equal to 350 by 10 years, that is 35 years, right? Now first of all we have introduced these various, what is data, or what is arithmetic mean. Arithmetic mean is the central tendency or representative value. In the next, now we shall solve the various problems of the exercises of this chapter. Let us in the next video we will solve exercise 3.1, right? Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.